In the previous video, we simplified our previous WebSocket interface code to a much tighter and easier to manage version. And I think it's worth showing both files side by side. So our original code involved all of the setup and all of the global state and all of the looping all in one file. In our current version, our main function, our main file, has been simplified to just calling setup and loop step on our single object. And we've added those implementations into our heartbeater class. And given how messy this code was, I actually missed an important piece of functionality, which is inside loop. We actually need to make sure we're updating the WebSocket and handling the heartbeats. So that's functionality that needs to go inside of our loop step function. So the important thing here is, even though we've refactored our code into multiple files, I think once you get used to the C style of coding, you'll find that this file is a lot harder to read and manage than this one, even though we've split up our functionality across multiple files. And the reason for that is because what we'd like to do now is create a second object. Something like LED blinker. And inside our main function, we'd like to run basically the same code that we did for our WebSocket module. We'd like to call setup here. And inside loop, call loop step. And this is essentially how the rest of our semester will look. We'll initialize an object, we'll call it setup function, and we'll call loop step. One slight change here is that aside from our WebSocket heartbeat interface, each of our subsequent objects will need to take in whether or not they should be enabled or disabled. So they can take in the current state of the WebSocket. And it might make more sense to have the loop step of our LED blinker object take in a Boolean. So for example, I could compare this to forgetting my C++ syntax a little bit. So this is essentially the pattern that the rest of the semester will find, or will resemble. We'll later on have a compass object. We'll call loop step in here. We'll have our inertial measurement unit. And so on. And this code will be a lot easier to read, and the control flow will be a lot easier to read when we don't have to worry about all of that code existing all in one place like this. For now, let's work on this LED blinker object, which it's rightfully complaining doesn't exist. Let's start by creating a file for it. So currently we have our WebSocket heartbeat.h. Let's create an LED blinker.h. Inside here we'll have our LED blinker class. And it of course is going to have a constructor. It'll have a setup function and a loop step function. Let's see what we need to copy over from our original example. Well, we should probably have our LED state. And in this case, we don't need to use global variables like we had before. Instead, this will just be a member variable. And that should be initialized as part of the constructor. And let's initialize to off. I'm happy to answer any questions you might have about C++ syntax and why I'm doing it like this, and not, for example, like this. Both are technically valid and both will have the same end result, but it'll actually produce slightly different assembly code for these two different versions. But I will leave that for questions that you can ask on Slack or in class. And for now, we'll just stick with one version. And now we need the rest of our functionality. We need a blink interval. And that should be a value that the user passes in. And we need to initialize our last time. That one the user does not have to pass in. We'll initialize that to 0. And this line's getting long. Let's see what the auto formatter does when I split the line a little bit. What other state do we have missing? What do we do in the setup function? Looks like our constructor, which gets called immediately, can just initialize our variables. And our setup function can set the pin mode and the initial value of our LED, so setting it to off. The next place that we use our LED functionality is down here for blinking the LED. Now we have some choices to make in our API here. I think it does make sense to make this a bool, and we can say is enabled, which means inside of our bracket here, we can use is enabled. Give a type to our now variable. And the rest of this is likely to function the way we want it to. After refactoring, it looks like the main complaint here is that we haven't included the file. And a default constructor is being called, but we're not actually initializing the interval like we'd like to. And now it appears that we've copied over all of the functionality that we need from our original file. The original file has some code for sending messages that can be plotted on a web browser. We'll ignore that for now. It's more than we need for this simple example. So looking at our refactored code, it really nicely just fits in 24 lines. And it's easier to map it to the code we had before, which was initializing global state and update periods, initializing non-trivial global states, and then doing short updates. So let's see if we've managed to do that. We have our constructors being called, which does initialize things like our heartbeat intervals. We have more complex setup happening here, like setting the pins of the LED, connecting to Wi-Fi inside the WebSocket heartbeater. And then are these quick updates. Let's look for any long-running code inside either of these. So if we look at the definition for the WebSocket heartbeater, it has no loops, just some if statements here, and we can assume that WebSocket loop is also a short enough function. And it doesn't look easy to jump into. Let's see if we can see that code. Looks like it looks for handling new clients, calling web server core loop, and if we keep going down this rabbit hole, calls WebSockets yield, handles client data. So there are some loops here, but it's just looping over the clients. So this appears to be pretty quick code. So I think we can be pretty sure that loop step for the WebSocket heartbeater is quick code. How about the LED blinker itself? No loops here either. Checking if enabled. If we're not, we just run one line of code. If we are enabled, we check the time and then blink the LED if it's time to blink the LED. So I think we can easily see that this is satisfying that high-level interface that I mentioned at the beginning. All that's left to do is to test this out and see if it works, which we'll do in the final video.